Hi, my name is Matthew Mills, and I will be going over the design phase 2 presentation for Team 47, automatic affordable solution to vitamin needs. I'm going to start us off with our mission statement here. Our product aims to generate profit while assisting customers who have a tendency to forget their daily medications. Our mission statement, which is pretty much just being able to develop a device that assists users in being able to remember to take their medication or vitamins, really just stems from the fact that as college students we tend to have busy lifestyles, and that's something that can tend to fall by the wayside in the morning when you're rushing to classes is, oh, I forgot to take my daily multivitamin. So something to kind of remind you to keep on top of that is what we were shooting for. So our primary market would be college students, and then you can see secondary markets. It could potentially have some uses in the medical field, and just people with busy lifestyles in general. From our design phase 1, we came up with several different customer needs through discussion and polling potential customer bases. So the things that customers found most important were being able to hold a decent amount of doses and the actual ability of the device to remind you. So we broke that down into the device needs to be able to hold at least 7 doses of medication, and then having some sort of reminder, be it auditory, visual, like a flashing light or something. So you can see here in our customer needs table, the needs of importance 5 is the 7 days of doses and the automatic dispensing with the reminder. A couple others, keep pills separated so they don't touch each other. We had cut medication, and privacy, to make the device opaque so people can't see. Those were a little bit lesser concern. This is our concept combination table. So in order to solve some of those user needs, we came up with a couple of different sub-solutions. Each of our different sub-functions, so the device needs to receive power, obviously. It needs a way for us to load medication or vitamins into the device. Needs a way for the user to program it, to tell it what time it wants to dispense. That needs a way to notify the user, obviously, a display so you can see what time you're selecting, and then a motor which will actually rotate, or some sort of mechanism to dispense the medication. So through our concept generation exercises and our 6-3-5 method, each one of our team members came up with a different concept combination to solve these problems. So here you can see each one of these different colored lines is a different concept combination. We'll go over these in more detail on the next slide. But each one of us, completely independently, chose a couple different solutions to our sub-functions and kind of ran with it. So you can see here what we actually ended up doing. Here's mine, it's the blue line on the previous slide. We've got a sort of coffee maker looking device. It's powered by batteries. It's got a hatch in the top that you open up to load the medication in. Some buttons for the user to program at dispensing time. A speaker on there, or like a little piezo type thing. LCD screen, and then a stepper motor, which will rotate some sort of dish with medication in it, and then it'll kind of just fall through a hole. We got Andrew over here. His is powered by the wall. Dispensing is voice activated. You'll get a Bluetooth notification, and then a servo motor will dispense your vitamins. Here we got Tate. You just load up a bottle up in the top of whatever pill you want dispensed. You got a touchpad for programming the device. A light will blink to alert the user. We got an OLED screen and a DC motor. Giselle over here, battery, also hatch on the top. Also, he's got a touchpad, a speaker, an OLED, and a stepper motor. When we presented this with our gallery method poster, we received a little bit of feedback that maybe our capacity is a little bit too small, that 7 doses is kind of erring on the smaller side. So we might want to up that in the future. And then we also got the device's size is a little bit of a concern. So try to keep that as small as possible when we were designing later on. Here we have our concept screening table. So we have each of our concepts listed here. Tate is our reference, is kind of the middle of the road. And then our selection criteria, we've got portability, electrical complexity, so that's more of a consideration for our design and manufacturability. The dispensing mechanism, ease of use for the user, and the notification method. So our reference gets all zeros, and then if our selection criteria we believe to be better or worse on a certain concept, it'll get a plus or minus. So what ended up coming out on top was my concept and Giselle's were both in the lead, and then Andrew and Tate's ended up combining those, seeing if we could work with that a little bit more. Then we get down to our concept scoring. So Andrew and Tate get combined into our overall reference, end up with a score of 3, it's baseline. We gave our selection criteria some percentage weights of importance, so dispensing mechanism and electrical complexity being very important, notification method coming right in behind them, and then portability, not so much of a concern. We're not really anticipating users going to be taking this device on the road very much, kind of more of a stay in your kitchen, sit on the counter kind of thing. So my concept ended up coming out on top with a score of 4.2, rank 1. Giselle's was just a little bit better than the combined overall reference concept. So yeah, we ended up kind of running with my concept for a little bit of our final design. Here you can see a reminder once again of what my original concept sketch was, and then the different sub-functions from the concept generation table that I had selected. So we got the battery, the hatch in the top to load the vitamins, buttons and an LCD for the user to program the time, speaker to let them know when the vitamins have been dispensed, and then we got a stepper motor here. So in a little bit of the final design for the CAD, we've got a, here you can see the hatch open and the vitamin dish removed. Here's our stepper motor. Then we've got this rotary dish with 8 different compartments that will attach to the top of the stepper motor, and you can load your medication into each one of those little sections. Here is kind of a little bit hard to tell from this angle. There's a cutout here, so when the Arduino registers that the time that the user set is what the time is currently, the stepper motor will rotate 45 degrees. That's 360 divided by 8 for the 8 compartments. And say whatever medication is in this compartment, when it rotates, it's just going to fall through this hole here into a little dish that the user can pick up to put that medication into their hand. Here you can see a little bit of our electronics. We got Arduino breadboard, our LCD screen on the side, 9-volt battery, we're going to have a couple of those, and then our little PSO. Alright, so here's our final design. That's the dish I was talking about earlier. So the vitamin's just going to fall in there, and then put them in your hand, take them, whatever, however you want to do it. So yeah, that is going to wrap up our presentation. Thank you very much.